So our small block Chevy obviously has a standard water pump in it, and I've discovered that someone put a reverse rotation water pump in it, and I figured I'd talk a little bit more about that because I looked on the internet quick for this impeller to make sure that it was indeed reverse rotation, and for this particular impeller design I found virtually nothing. And what I did find, 50% of the people said that's a standard rotation impeller, and the other 50% said that's a reverse rotation impeller. So for once and all, we're going to solve this question. So these weird markings inside here, if you look down here, you can see a lot of pitting in the casting, and that's not just from rust. That looks like that is the start of cavitation, removal of material through cavitation. It's and that's what happens when you spin your pump the wrong way. Comes in here and it's supposed to be pushed to the outside of this casing by the vanes on the impeller, and if it's not doing that, then yeah. So you can see, so this pump spins this way on this engine, and you can see how the cups are pushing the water. And anytime you're moving water, you don't want the cups pushing it. The cups should face, the cups should push into the water. So you want the concave portion away from the water as it spins. There's various stampings of these impellers, and you can see these impellers are kind of, just kind of straight, except for the actual end on the impeller, which is cupped. Some of them have more of a curved shape to them, and those are easy to tell. If you look up this shape impeller on the internet with these little cups on the end, you will find virtually nothing about which way they're supposed to spin. But I can tell you from experience that this rotor is meant to spin this way, which is counterclockwise. If you spin it this way, you'll get little to no flow, and you'll start to cavitate in your pump under some conditions, so especially high speed. So you don't want that. Now, this video, we're only talking about the direction of the shaft of the impeller. We're not talking about reverse flow engines where the water flows from the block to the water pump and then to the radiator. We're talking about standard flow, and then which direction the pump shaft turns. So standard flow is from the radiator to the pump to the engine block. So some engines with a reverse rotation pump shaft have a serpentine belt, and because of the setup of the belt, it has to spin the opposite way of the crankshaft in the engine. Standard rotation spins the same way as the shaft in the engine. So you have to know which pump is the right pump for your engine. They look the same from the outside. There's no way to tell without looking down inside at the impeller and seeing which way the vanes go. Or if your manufacturer says this is a counterclockwise pump or this is a clockwise pump, that's your main difference. So you have to pay attention when you put one of these in, because if you put one in that's made to spin the wrong way, you'll get that pump cavitation, possible major cooling issues, possible minor cooling issues. You still might get a little bit of flow of water through the engine, as I will show in my demonstration, but you won't get the full magnitude of the flow, and it probably won't build up the pressure in the system like your radiator cap is rated like 16 psi, and it'll never come anywhere near that pressure. It might build 1 or 2 psi tops if you're spinning the impeller the wrong way. Obviously there's lots of fluid dynamics involved in impeller shapes, but the basic thing to remember is you don't want to cup the fluid. You want the curve to push against the fluid of your impeller. And there's many different impeller designs in these small block Chevy pumps, and you can look online and see, well, which way does my impeller spin? And there's lots of information for some impeller designs and there's not for others. And specifically this one that I have here, it's almost impossible to find any information on the internet about which way this impeller is supposed to spin. So for once and all, we're going to solve that question. So some quick information on the small block Chevy pump, if you're not familiar. They will have a casting stamped in here, but that doesn't necessarily tell you if it's reverse rotation or standard rotation. That's entirely based on the impeller inside the pump. You have weep holes. These are on the outside of your bearing. If water gets through your bearing assembly and starts dripping out this weep hole, that means your seals inside the pump are bad. It's time to replace it. So if you see coolant around here top or bottom, you're done. It's time to replace your pump. Fluid goes here from the radiator into the pump, into the center of the impeller, and then it's shot outward. It's pushed outward by the impeller to these ports into the block, into each side of the block, and there's a bypass hole. There's a bypass hole here, which is a continuous bypass from the into the block. So that's built into the system. There's always a coolant path through here. So coolant pressure can, equalize. If your engine is not up to temperature yet, you won't have air in the top of your engine, in theory. That's what the bypass does. This down here goes into the water jacket. Don't forget to put sealant on that bolt when you put it in. Of course, the back of the impeller, let's look at that. So this is obviously the back of the pump. This is the impeller that spins along with the fan on the front of the engine. And you can see this impeller design looks like a star. Some of them have definite curves in them, and those seem to be the more common one. Those can be also stamped steel, but they seem to be a better impeller design. This impeller design seems to be a lot less efficient, but you see it in cheap pumps a lot. And the distinguishing feature of this is it's basically just the outer part of the impeller here is the only part that sticks down, and it has a cup in the end of it. And it looks like it's straight that way. And if you look at the center line of the shaft and the impeller, you can see that the cup is pushed this way, or in this case, this way. So obviously there's a reverse version of this that's mirrored, flipped, and that's for a standard rotation pump. This is a reverse rotation pump. Do not get that wrong. Some people on the internet will tell you that this is a standard rotation pump. It is not. So those are the main features of the small block Chevy pump. So now let's look at how it actually works on standard rotation versus reverse rotation. Let's take some quick look at some impeller designs. I'll show you real quick and what the impeller looks like from the back side of the pump and which way the impeller should spin. So kind of a quick ID so you can look at your impeller and look at this and see which kind of pump and impeller you have. So the first one we showed there is the one we're dealing with in this case that I could find very little information about online. The second one I'm going to show here is more of a conventional one that you'll find. It's more common. You can see the actual curve in the impeller as well as the curve away from the center of rotation. And those are easy to tell which way they're supposed to spin. Obviously, the angle of the vanes will vary a lot between different impeller designs, but the ideal you want is that always the cup is pushing towards the water, the concave side is away from the water, and the convex side is the side that's actually pushing the water. This is obviously for any impeller designs where the inlet for the water is in the center of the pump, and the idea is that it pushes the water towards the outside of the pump housing, towards the exit of the pump. So I've cut a groove in the end of the pump so I can use this power drill. So here's the way it would conventionally spin on the engine we had it on, which is a standard small block Chevy. Alright, let's try this. So we should see water through there. Getting a little bit. Let's put it in reverse now. There, we're getting a lot. See that? See there, we don't get a lot. We get a little bit, but not near as much as when I turn it in reverse. Well, counterclockwise rotation is what I mean. So what are the symptoms of a bad pump versus a reverse rotation pump in the wrong application? A pump with a worn, very worn or bad impeller, or if the gap in the impeller is too big, it will reduce flow. You might still have a little flow, so you might not have much, if any, overheating, but you'll have reduced flow, and you might have overheating under, idle conditions or when the pump's spinning really slow. The same thing could happen with a reverse rotation pump, but depending on the impeller design, some impellers react differently when you spin them backwards versus forwards. Straight vane impellers, which I haven't mentioned, but straight vane impellers can spin either direction. So really the sign of a bad pump, bad bearings, obviously you'll see coolant through the weep holes, and that means coolant is going past the seals on the pump. But that doesn't mean the pump itself is bad, that just means the seals are bad. But generally, reduced flow and overheating and a non-pressurized system, those are the symptoms of a bad pump. Unfortunately, those can also be the exact same symptoms of a pump in the wrong application, reverse flow versus standard flow, so it's hard to tell. In this truck, we were not overheating at all because we were still getting a little bit of flow, enough to move the coolant through the block, and this engine does not run hot, apparently. I haven't checked the tuning on it yet. Maybe they have it running really rich to keep it cool. I don't know. I'll have to check that. But generally, if you put a reverse rotation pump in, you'll have symptoms like overheating and it won't pressurize the system. The main problem is with a reverse rotation pump, it won't pressurize the system. You're not getting the effect you need from the impellers. When a pump starts to go bad and it's in the right application, you might still see a little bit of pressure, but you'll see the pressure reduce as the pump gets worse and worse. Reverse rotation, that won't happen. You'll never build up to high pressure, unless you have a miracle of an impeller design. But you won't get a pressurized system, and you can tell that by squeezing your upper radiator hose. If the system is properly pressurized, if you can just easily squeeze it when the system is running and the thermostat is open, you're not getting any pressure in your system with the radiator cap on. And of course then you can pressure test your system and check for leaks and check your radiator cap and all that. And if all those check good, then start suspecting your pump. If you made it this far in the video, we appreciate you watching. We appreciate all of your input, comments, questions. We really appreciate subscriptions. Helps the channel grow. Any likes, comments, questions you have, leave them down there below. And as always, thanks for watching.